Are we ready for another math lesson? No! Are we going to do it anyway? Yes. Why? Because we have to. This is Unit 8, Lesson 6, I think. Linear change. So if we look at this lovely little diagram, we have matchsticks because you should always play with fire. No, you shouldn't. And we're building squares out of them. So you can see in the first square, it took 4 matchsticks. To make 2 squares, it took 7. To make 3 squares, it took 10. What that means is that to make 4 squares, you can see here that our rate of change, our common difference, is 3. Each time we're adding 3 matchsticks to make another square. So to make 4 squares, we need 10 plus 3, which is 13 matchsticks. To make 5 squares, we need 13 plus 3, which is 16. We need 16 matchsticks. Our common difference is 3, and this is an arithmetic sequence. I would call it arithmetic, but apparently I'm a redneck. All right, here's our next problem. If we have this table of information where we have the number of squares made, whoop, and the number of matchsticks, whoop, which is what we just dealt with, then the formula we're dealing with is a sub n is equal to 3 times n, so 3 times this number plus 1. So 3 times 1 is 3 plus 1 is 4. Look at that, it magically works. So true or false, the sequence negative 89, negative 95, negative 101, negative 107 describes a linear change. Explain your answer. We'll work through this together. So what we need to do first is take the second number in the sequence and subtract the first. You can do this with any 2 adjacent numbers. So we're going to take negative 95 and subtract negative 89. When you're subtracting a negative, it becomes a positive. So we have negative 95 plus 89 is equal to negative 6. That means that our rate of change, or our common ratio, is negative 6. I guess it's not a common ratio, it's a common difference. It's morning. I'll get there. We need to double check this with other numbers to make sure that it's the same for everything. So negative 101 minus negative 95, which would be plus 95, is also negative 6. Negative 107 plus 101 is also negative 6, so it is true. The sequence has a common difference of negative 6. Thus, it is an arithmetic sequence. Since it is an arithmetic sequence, it describes a linear change, which means it makes a nice, pretty, straight line. Determine whether the following sequence describes a linear change: negative 16, negative 7, 2, and 11. We will work through this one together as well. The first thing we need to do is find out if the rate of change is the same for all of these different numbers. So we're going to take 2 numbers that are next to each other. I did this wrong. You're supposed to take negative 7 and subtract 16, but you know, whatevs, we'll do it like this. And we see that the rate of change is 9. If we do 2 minus 7, it ends up being 2 plus 7, which is 9. 11 minus 2 is 9. I'm sorry that I put those numbers in backwards. It's me. I'm amazing. Math is not my strong suit. The sequence is constantly increasing, and I spelled increasing wrong, by 9. Thus, the sequence is an arithmetic sequence and describes a linear change. It has the same rate of change between each set of consecutive numbers, and that means it has a nice, pretty straight line. Determine whether the following sequence describes a linear change: 39, 41, 44, 48. So we need to figure out what that rate of change is. So 41 minus 39 is 2. 44 minus 41 is 3. That's a problem. 48 minus 44 is 4. Those are not the same number. That means that it's not increasing at a steady rate. The sequence does not have a common difference because it's 2, 3, 4. It needs to be like 2, 2, 2, 3, 3, 3, 4, 4, 4. That doesn't work. So it's not an arithmetic sequence. Thus, the sequence does not describe a linear change because its terms are not increasing constantly. That's going to have a wonky line, not a nice, pretty straight one. Determine whether the following sequence describes a linear change. Negative 5/3, negative 2, negative 7/3, negative 8/3. Let's do it together. So if you take negative 2 and you subtract negative 5/3, what do you get? That ends up being negative 2 plus 5/3 because we have two negatives, and that gives you a negative 1/3. If you have negative 7/3, subtract 2, that is going to be a different number. We obviously, if you have 2 over 1, then you're going to end up having to get a common denominator. So it's going to be, we have to multiply it by 3. So 6 over 3. Negative 7/3 minus negative 6/3 is going to be like negative 13/3. That's not negative 1/3. So they don't match. You can tell just by looking at those numbers that you have something over 3, a solid number, something over 3, something over 3. It's not going to work. It's just not going to be a nice, pretty answer. So each pair of terms does not have, oh, it does have a common difference, it says. So I'm sitting here talking about all of this and I'm wrong. I guess each one is 1/3. Well, I'm going to have to edit this out and try again. Hey, would you look at that? I completely screwed it up. Let's go back and try again. Okay, determine whether the following sequence describes a linear change. We have negative 5/3, negative 2, negative 7/3, and negative 8/3. I hate fractions. So it says negative 2 minus negative 5/3 is equal to something. When you have a negative subtracted, it becomes add. So negative 2 plus 5/3 is equal to negative 1/3. If we look at negative 8/3 minus 7/3, that would be negative 8/3 plus 7/3, and that would be negative 1/3. So each pair of terms does have a common difference, and the sequence is therefore an arithmetic sequence that describes a linear change. You have to make sure and check more than one consecutive term set to make sure that it carries all the way through. Determine whether the following sequence describes a linear change. 5/2, 5, 10, and 20. Well, 5 minus 5/2 is 2.5, and 10 minus 5 is 5, so obviously that's not going to work. The sequence has no common difference. Thus, it is not an arithmetic sequence and does not describe a linear change. How you determine this is it needs to have one common answer when you subtract consecutive terms. That's all that you need to look at. Okay? A company is offering a job that pays $45,000 for the first year and offers a $750 increase each year after that. Create a sequence that corresponds to the salary for the first 5 years. So what we know is the first year you get $45,000. The second year you get $45,000 plus $750. So the second year you're going to get $45,000, $750. You continue that pattern for the third year, the fourth year, and the fifth year. And this is an arithmetic sequence because it has a common difference of 750. Every single year, you're increasing by a steady amount. That makes it an arithmetic sequence. An airplane flying 38,000 feet above ground begins descending at a rate of 2,500 feet per minute. Create a sequence that corresponds to the altitude of the airplane. So we know that at 0 minutes, we're at 38,000 feet. Before we start descending, we're at 38,000 feet. After 1 minute, it's 38,000 minus 2,500 because we're descending at a rate of 2,500 feet per minute. So after 1 minute, we're at 35,500 feet. After 2 minutes, it's 35,500 minus another 2,500 feet. So after 2 minutes, we're at 33,000 feet. You just continue that pattern down for all 4 minutes. This is an arithmetic sequence because it has a common difference of negative 2,500 feet. A water tank containing 1,400 gallons leaks at a rate of 8 gallons per week. Create a sequence that corresponds to the remaining amount of water in the tank. So we know that at the beginning, when you first fill it up, it's got 1,400 gallons in there. After 1 week, it's leaking 8 gallons every week, so you have 1,392 gallons. After 2 weeks, you have 1,384 gallons. This is an arithmetic sequence because every week it's losing 8 gallons. When it has a steady rate of change, then it's an arithmetic sequence. Logs are stacked in 8 rows such that the top row has 24 logs and each row has 3 more logs than the row directly above it. Create a sequence that corresponds to the number of logs per row. So we know that row 1 has 24 logs. It told us that. Row 2 has 24 logs plus 3 more, so that's 27. You just follow that pattern clear through to row 8. This is an arithmetic sequence because it has a steady rate of change, which is 3. All right, we have a picture, so this means that this problem is all yours to solve. A plant has a height of 4.15 inches and grows by 1.25 inches per week. Create a sequence that corresponds to the height of the plant from week 0 onwards. Name at least 3 terms of the sequence, including week 0. So you need to give me 3 terms in the sequence starting at week 0. Pause the video, do that, come back. Okay, we know at week 0 the plant is 4.15 inches. It tells us right there, okay? We know that every week it's going to get 1.25 inches taller. So at week 1, we have 4.15, which is its initial height, plus 1.25, which means at the end of week 1, your plant is 5.4 inches tall. And at the end of week 2, it's 6.65 inches tall. Here's another one with a, ooh, I did not mean to do that. Here's another one with a picture. It says the temperature in the city was 6 degrees Fahrenheit at 10 p.m. and decreased by 5 degrees each hour. Create a sequence that corresponds to the temperature from 10 o'clock p.m. to 3 o'clock a.m. So pause the video, go ahead and do that, come back. So we know at 10 o'clock when we start, it's 6 degrees Fahrenheit. At 11 o'clock, it will have lost half a degree, which means it's now 5 degrees. That doesn't make any sense. It should be 5.5. That's interesting. Okay, I think I just typed it wrong. It should be 5.5. At 12 a.m., it loses another half a degree, so now it's 5 degrees. At 1 a.m., it loses another half a degree, so it's 4.5. And you could just continue through the table until 3 a.m. because that's what it tells you to do in the instructions right here. Okay, this is practice question number 1 at the end of your lesson. The tables for a party are seated as 4 people at 1 table, 6 people at 2 tables, and 8 people at 3 tables. Use a sequence to determine how many tables would be needed for 16 people. Pause the video, go do it, come back, we'll go over it. Okay, so we know that, oh my gosh, I'm changing the size again. I'm grabbing the wrong slider. I apologize. We know that the tables, 1 table holds 4 people, 2 tables is 4 people plus 2 more chairs, which is 6 people. We know that 3 tables is 4 people, this should say 6, I apologize. 6 people plus 2 will be 8 people. And we're going to continue that pattern. Every time we're adding 2 people with 1 more table. So 4 tables will hold 10 people, 5 tables will hold 12 people, 6 tables will hold 14. And here's the answer it wants us to find. We need to find how many tables we need for 16 people. We need 7. Okay, moving on with the lesson. The linear function is written as either f of x is equal to mx plus b or y is equal to mx plus b, where m is the slope and b is the y-intercept. To find the slope, you do m is equal to y2 minus y1 over x2 minus x1. And these y and x's are coordinate pairs that you have, that you can graph. So we have this table here about the freezing and boiling points of water in temperatures Fahrenheit and temperature in Celsius. So create a formula and graph that show the relationship between the temperatures in Fahrenheit and Celsius. We'll do this together. Go away, little pop-up. So let x represent the temperature in Fahrenheit and let y represent the temperature in Celsius. The freezing point of water is denoted by the point 32.0 and the boiling point of water as 212, 100. So we're going to use slope formula to find m. So 100 minus 0 over 212 minus 32 is equal to 100 over 180, which reduces to 5/9. Our slope is 5/9. Our rate of change is 5/9. Continuing on, the slope is 5/9, which means that when the temperature in Fahrenheit increases by 9, its corresponding temperature in Celsius increases by 5. With a slope of m equal to 5/9, the function becomes y equals 5/9 times x plus b. However, the y-intercept b is still unknown. It didn't give us that information in the original problem. To find the y-intercept b, use any of the ordered pairs you've already found. We're going to use the point 32 and 0. Okay, so we take our formula that we've already figured out, y equals 5/9 x plus b, and we're going to plug in the points that we have, 0 for y and 32 for x. So 0 equals 5/9 times 32 plus b, which then is 0 equals 160 over 9 plus b, which then equals b is equal to negative 1/69 because we switched the sides thereon. Okay, we got b over on it by itself, which leaves 160 as a negative, 1/69 as a negative. This is what the graph looks like if you plot those 2 points. We only have 2 points, but it is perfectly okay to have 2 points when you have a linear equation because it's a beautiful straight line. You can do that. That's what that's going to look like, that rate of change. This allows us to go, okay, if it's 80 degrees Fahrenheit, then I can come right up here and figure out it's right there for Celsius. A water tank develops a leak. Initially, it holds 500 gallons of water. However, it loses 5 gallons per week. Create a formula and graph that show the relationship between the number of weeks and the amount of water remaining in the tank. Let's do this together. Since the tank loses the same amount of water each week, this situation describes a linear change and can be represented by a linear function. Let x be the number of weeks and y be the amount of water remaining in the tank in gallons. The tank loses 5 gallons per week, thus the slope is m equals negative 5. The initial number of gallons that the tank has is 500, therefore the y-intercept is b equals 500. The function that represents the relationship between the number of weeks and the amount of water remaining in the tank is y equals negative 5x plus 500. To graph the function y equals negative 5x plus 500, start with the y-intercept of 0, 500, then use the slope m equals negative 5 to find another point on the line. So what they did was they went over 5, 1, 2, 3, 4, 5, and down 1, then over 5, down 1, over 5, down 1, over 5, down 1. Okay? That's how you do a negative slope. Normally you would go over, up for positive. The number of chirps a cricket makes per minute is linearly related to temperature. A cricket chirps 10 times per minute when the temperature is 40 degrees Fahrenheit and 210 times per minute when the temperature is 90 degrees Fahrenheit. Create a formula and graph that show the relationship between the temperature and the number of chirps a cricket makes. We'll do this together. Temperature is the independent variable. Doesn't change no matter what. Temperature is temperature. And the number of chirps a cricket makes is the dependent variable. It depends on what the temperature is of how much a cricket chirps. The problem tells us that a cricket chirps 10 times per minute when the temperature is 40 degrees Fahrenheit. Represented as an ordered pair, this looks like 40, 10. The problem also tells us that a cricket chirps 210 times per minute when the temperature is 90 degrees Fahrenheit. As an ordered pair, this looks like 90 to 10. Solve for the slope m of the line containing the points 40, 10, and 90 to 10. So we have 210 minus 10 over 90 minus 40, which simplifies down to 200 over 50, which is 4. The slope is 4, which means the number of chirps per minute increase by 4 when the temperature increases by 1 degree Fahrenheit. Plugging 4 in for the slope gives you the function y equals 4x plus b. We can use either one of the ordered pairs to find the y-intercept b. We're going to use, for example, the first one, which is 40, 10. So y equals 4x plus b is what we figured out because we know the slope. Plug in our first ordered pair, so y is equal to 10, x is equal to 40. 10 equals 4 times 40 plus b. So 10 equals 160 plus b. Now we just need to get b by itself, so that ends up being b equals negative 150, because we're going to subtract 160 from each side, and then I just flipped them because we're used to seeing the variable on the left side and the answer on the right. The y-intercept is b equals negative 150. This means that when the temperature is 0 degrees Fahrenheit, the cricket makes negative 150 chirps per minute. That doesn't make sense in the real world, but we need that number to create the formula. So we have to have that answer, but in the real world, a cricket can't chirp negative times. So this is what the graph is going to look like. The function that describes the relationship between temperature and the number of chirps a cricket makes is y equals 4x minus 150. But if you notice in this graph, it doesn't go into the negative values because we can't have negative chirps. You can't have a negative number of chirps. That's illogical. So you want to buy a new TV for your room. You start by saving $100, then save an additional $25 per week. The table shows your progress so far. So at the beginning, you had $100, then each week you save an extra $125, which you can see on that table. An extra $25, not $125. This is what the graph is going to look like. Oops, sorry, I went too far forward. So our formula is a sub n is equal to 100 plus n minus 1 times 25. So a sub 1 is going to be 100, and d, the rate of change, is equal to 25. So to find our slope, you just take two consecutive terms. They took the last two, and they did 175, and it should be minus 150. I don't know why I typed 100. And 3 minus 0, and you end up with 75 over 3, which is equal to 25. So the formula is f of x is equal to 25x plus 100. And that is what your graph is going to look like. Okay, your turn. Assume that the amount of gas, Y, remaining in a gas tank after driving for X hours changes at a constant rate. After driving for 3 hours, 10 gallons of gas remain in the tank. After driving for 5 hours, 6 gallons of gas remain in the tank. Create a formula that shows the relationship between the number of gallons remaining and the number of hours driven. Pause the video, go do that, come back. Okay, so first we're going to create ordered pairs. We have 3, 10, and 5, 6. Both of those were given to us in the word problem. So using those ordered pairs, we're going to solve for the slope. M is equal to 6 minus 10 over 5 minus 3, which gives us negative 4 over 2, which reduces to negative 2. Our slope is negative 2. So we're going to use either ordered pair to find the y-intercept b. We're going to go ahead and use the first one. So our slope formula gave us the formula y equals negative 2x plus b. Plug in our x and y values. That gives us 10 equals negative 2 times 3 plus b. Negative 2 times 3 is negative 6. So now we have 10 equals negative 6 plus b. Add 6 to each side and you end up with b equals 16. That's our y-intercept. So our final formula is y equals negative 2x plus 16. Here's another problem for you to solve. Use the table to create a formula for the given information. Go ahead and pause the video, do that, and then come back. Don't cheat, don't just use me. You need to know how to do this. Pause the video. Okay, so here's our table just shrunk down. So first you have to calculate the slope. You're going to take two adjacent terms. They're using the first two. So 250 minus 125 over 2 minus 1 gives you 125 over 1, which is just 125. So the slope is 125. And then you're going to create the formula. We know that the initial time for this is 0 minutes and the initial distance is 0 feet. So that makes the y-intercept 0. So your final formula is y equals 125x plus 0, or just y equals 125x. 0 is just a placeholder. It doesn't have to be there. Okay, back to our practice questions. This is number 2. Use the table to create a formula for the given information. Pause the video, go do it, come back. First thing is to find the slope. They're using the first two numbers in the table. So we have 150 minus 75 and 2 minus 1. That gives us 75 over 1, which is just 75. And then the formula is now y equals 75x plus b, because we know our slope. We're going to plug in our first set of terms here, our first coordinate pair. So 75 equals 75 times 1 plus b, which is just 75 equals 75 plus b, which means b equals 0. If I subtract this 75, subtract it from over here, that leaves us with 0. So our final formula is y equals 75x plus 0. Quick check question number 1. So I don't answer these ones for you, but I will tell you what you need to do. Using the equation t equals 13n plus 7, create a sequence that corresponds from the first term to the fifth term. So what you're going to do is take number 1, plug it in for n. So your problem would be 13 times 1 plus 7. Solve that, simplify it, and that's going to give you your first term. Then you're going to take 2 and plug it in for n. Solve it. That's going to give you your second term. Do that all the way through number 5. So 1, 2, 3, 4, 5. Quick check question number 2 says create a formula for the points 1, 5, 2, 7, 3, 9, and 4, 11. So there are several ways that you can solve this. You can use the 2 consecutive points to do slope formula, find the slope, which is going to go into, this is the y-intercept, so slope goes here, which is obviously going to be 2. And then you need to figure out the y-intercept by taking like this pair of points, plugging it into your formula of y equals 2x plus b. So you'd have like 5 plus 2 times 1 plus b, get b by itself, and then you have this point, which is obviously going to be 3. And then you need to figure out, you know, if it's just plus or minus here and plus or minus here. That's all you really need to figure out. You could also take these, plug them into technology like geogebra.org and graph the line and look and see if it's a positive or negative slope and figure it out that way. There's several ways you could figure this one out. Okay, go away. Quick check question number 3 says which graph accurately depicts the correct formula for the points 1, 5, 2, 7, 3, 9, and 4, 11. This is really easy. You just need to find the point 1, 5. So you do the x value first, then the y, and see which of these has all 4 points on it. Back to the lesson. You are working with an arithmetic sequence for which a sub 1 is equal to 6 and d equals 10. D is the rate of change, the slope, whatever you want to call it. Graph the first 4 points of the sequence. What is the rate of change? So we know that point 1 is 6. That means that its coordinate pair is 1, 6. Our second point is 6 plus 10 because we know the rate of change is 10. So our second point is 16, which gives the coordinate pair 216. Our third point is 16 plus 10, that steady rate of change, which is 26, giving the coordinate pair 326. Our fourth point is 26 plus 10, which gives 36, and the coordinate pair 436. Some architects are designing an auditorium. Typically, the rows in an auditorium are shorter in the front and get longer as you move toward the back. The architects are using an arithmetic sequence to determine how many seats should be in each row. They decided that the first row will have 10 seats and each row will increase by 12 seats every 2 rows. What is the rate of change and how would you describe it if you were to model it on a graph? So to find the rate of change, you're just going to figure out the first row has 10 seats, which is a sub 1, and we know that there's going to be 12 more seats every 2 rows. So 12 divided by 2 equals 6. The rate of change is d. And if you were going to graph it, this is what it would look like. The rate of change means that you're going to come up 6, 1, 2, 3. These are counting by 2s, so it's 2, 4, 6, and then over 1 for each point. Notice down here how big the 1 is. Each of these lines is not 1. Use the graph to help determine the key features of the arithmetic sequence. What is the initial value for the arithmetic sequence graphed here? What is the rate of change? So if we come and look at this, the initial value is right here. It's 1, 1.5, so the initial value is 1.5. because we're dealing with the y value. And the rate of change is how much it goes up and over each time. So to figure that, we use slope formula, which means 2 over 1. 2 minus 1 is just 1, so we're only dealing with the y values. So we have 3 minus 1.5 is 1.5, 6 minus 4.5 is 1.5. So the rate of change is 1.5. You can see 3 minus 1.5, 4 minus 3, 4.5 minus 3, 6 minus 4.5. It's steady, it's always 1.5. I can hear meowing and I don't know why. Just a second. It wasn't meowing, it was an alarm for my kids' live lesson for school. Okay, picture means this one's all you. What is the initial value of the rate of change on a graph of an arithmetic sequence with d equals 1/2 and a sub 1 is equal to 5? Remember, d is the rate of change or the slope. A sub 1 is your initial value. Pause the video, go figure it out, come back. Okay, the initial value is 1/5. And the rate of change is 1/2. What is the initial value of the sequence and what is the rate of change? Use the image to answer the question. This one is also you. I forgot to put a pretty, oh my gosh, wrong slider again, sorry. I forgot to add a little picture to it, so pause the video, figure it out, come back. Okay, the initial value is right there. So we have 1, 2, 3, 4, 5. So we have 1 and 6, and the rate of change is, we have 5, 6, 7, 8, 9, 10. So we go up 1, 2, 3, and over 1. The rate of change is 3. Here is practice question number 3. Does the graph accurately depict the formula 3/2 x plus 6? So 6 is the y-intercept. It's hard to see, but yes, it is crossing right at 6. And the slope is 3/2, which means it's going to rise 3, 1, 2, 3, and run 2, 1, 2 every time, which it does. So this is a correct graph. Here's practice question number 4. What would be the next point on the graph? So we just need to figure out the rate of change. We're going up 1 and over 1, 2, 3 every time. So we're going to go up 1 and over 1, 2, 3. So it's going to be 12 and 2 for the next point on the graph. Hey, I grabbed the right slider that right time. Practice question number 5 says, what is the rate of change in the graph? Again, all you have to do is come here and count. So we're going up 1, 2, and over 1. The rate of change is 2. Quick check question number 4 says, when discussing the key features of a linear graph, which of the following statements is true? The points will make a straight line. The initial value is always 0. The rate of change can vary along the graph. The points always have positive values. I will not answer this because it's on your quick check, but there is only one correct answer. And the final one is quick check question number 5. What would the next point be on the graph? And all you have to do is figure out the rate of change and then go up and over however many to figure out where the next point will be. It's finally over. And I don't know why it moved that little picture, but you need to see he's all evil. Okay, bye guys.